Hey guys, it's Professor Tiffany Martin, and this is Medical Microbiology, and I am going to talk in this video about chemical agents for controlling microbial growth, and we have moved to the highest levels. We started with low-level chemicals, so we get rid of some things, intermediate levels, and now we have reached the highest level of disinfection, and the actual definition of this highest level is sterilization. We are removing endospores, so everything in this category can remove endospores. So if that's a question, if that's something you need to know, how do I get rid of something that's forming an endospore? This is the category you have to be in. Okay, so let's talk about our options in this category. All right, the first option is oxidizing agents. And do you remember when we talked about in chapter 6 with reactive forms of oxygen? We said that O2 is not the problem. O2 is in the atmosphere. Again, this is your codependent friend. Has to do with number of electrons in valence shells and being stable. But when oxygen is not O2, when oxygen gets ripped apart, it becomes singlet oxygen, or it's in some of these other forms that have oxygen in it that's not balanced, different peroxides. Ozone is O3 or something. These are the types of oxygen that are good at stealing electrons. Because they steal electrons, they're very good at controlling the growth of microorganisms, because they'll steal the electrons and the organisms will die. Now, most organisms on this planet have a way to protect themselves against these oxidizing agents. We have the enzyme catalase. Catalase is able to take hydrogen peroxide, which I brought my bottle. There's my hydrogen peroxide. It's able to take H2O2 hydrogen peroxide, and the enzyme catalase, which is found in our muscle cells and in a lot of other organisms have the enzyme catalase, and convert it very easily into water and oxygen. So this is a way that we can get rid of these oxidizing agents. Microorganisms that can't protect themselves against these oxidizing agents are harder. So this is why hydrogen peroxide can be a high-level disinfectant. It will actually kill microorganisms, including endospores. Endospores are notorious for not being able to deal with reactive forms of oxygen. Most of the organisms that form endospores do that because oxygen is damaging. So this is why hydrogen peroxide can sterilize. It can get rid of endospores. Now, they say it's safe to use as an antiseptic, and that's for the most part true. They don't really recommend it anymore because the high levels that is needed to get rid of most of the bacteria can damage our cells as well, but it can be a very good way to get rid of endospore forming bacteria. Okay, so hydrogen peroxide is one thing sold over the counter. Peracetic acid and ozone are also oxidizing agents in this category. Ozone is a gas, and we can use that to treat drinking water. Peracetic acid is a liquid, and it's used a lot to sterilize medical equipment. It leaves no residue. That's a plus. It's not affected by organic matter. That can be a plus. So a lot of times after surgery, if there's equipment that cannot be autoclaved, can't handle the moist heat, but we need to sterilize it, peracetic acid is a good choice. Okay, so that is our oxidizing agents. What other ways do we have? What other options do we have to sterilize, to get rid of endospores? Aldehydes is another category. You've heard of formaldehyde, glutaraldehyde. Formaldehyde is a gas. It is very irritating. It is carcinogenic. It inactivates nucleic acids. That's why it's carcinogenic. It's going to cause cancer. Denatures proteins, inactivates nucleic acids, but it gets the job done. It's very high level. Now, once we are in this high level, we said low level had hardly any side effects, if any. Intermediate, you had to be careful with side effects. Once you get to these high levels, side effects is a big, huge issue. Formaldehyde in the right concentrations can be very damaging. A liquid form of formaldehyde called formalin is what we use to embalm dead bodies. So this can be very damaging. Now, formaldehyde, you may have heard this in laypeople terms. It's actually one of the ingredients in some vaccines, and this is an ingredient that the people who are very against vaccines will harp on, that these vaccines contain formaldehyde, and therefore you should not put these unnatural ingredients into your body. So there are some vaccines that have formaldehyde in it. So let's go back to what we know about formaldehyde. Yes, it is carcinogenic. Yes, it is toxic, but we know dosage is important. Formaldehyde, our blood just undergoing normal metabolism, we actually have small amounts of formaldehyde in our blood. It's part of normal metabolic pathways. There's small amounts. We have more formaldehyde in our blood. The amount of formaldehyde in some vaccines is so small that, again, it's the same thing as like having it already in your blood. Sometimes they have to put things in vaccines as preservatives. Sometimes they have to put some things in vaccines so that your body know it's something bad and will make that antibody, reduce those antibodies and have that immunological reaction. So yes, formaldehyde is a high level, but dosage. It's all about dosage. Okay, so keep that in mind. Glutaraldehyde is a little better than formaldehyde. It's also a little more expensive. No, dosage makes a difference. So percentages, time makes a difference. Glutaraldehyde at 10 minutes will get rid of a lot of things. It'll disinfect. Glutaraldehyde at 10 hours will also remove those endospores. Okay, so no time makes a difference when we're dealing with all this. All right, so that's another high-level disinfectant. Again, high level, very good, gets rid of endospores, but you have to deal with side effects. There are other types of high-level things that we can use with gas. We already mentioned chlorine dioxide is a gas that will get rid of endospores. So we can get rid of different types of microorganisms. It also denatures proteins and activates nucleic acids. They use gas a lot in hospitals, dental offices. They can be very good with things that you can't use moist heat on, things that chemicals are damaging. Sometimes the gas can get into nooks and crevices, so that's a good thing. We again are at a high level, so we do have to watch for side effects. It can be very hazardous, and because it's a gas, it can also be explosive. If we do use a gaseous agents, we have to make sure that the gas gets out. The good thing about gas is it gets in nooks and crevices. The bad thing about gas is it can get caught in nooks and crevices. We must make sure that it's all removed from that, so when you're using gas. But it's good for things. So think about heart-lung machines where you have lots of tubes and stuff. They'll use a gas to sterilize that. Sutures, things that are very fragile. Soft surfaces. Soft surfaces, a lot of things in the hospital now are disposable. You know, you get a pillow and you don't use that between patients. Before that they would use a lot of soft surfaces. They would use a gas to decontaminate because gas would penetrate, which things like liquid disinfectants, you spray it on top, it won't penetrate through. UV light won't penetrate through. But cleaning soft surfaces and fabrics, the gas would be able to get in there. So that's a good use of that. We use it on NASA, and we actually, if we're like going to take like a Mars rover out and we're going to take that to Mars, they'll actually sterilize the Mars rover, not to protect us from Mars, but to protect Mars from us. They don't want us to introduce any Earth organisms onto Mars that could potentially survive, maybe mutate and alter and adapt to that environment. So they don't want us to colonize another planet with our bacteria. All right, so that's a good use of gas. Again, most of these you can get rid of endospores, so high levels. All right, so that's high levels. If we're trying to get rid of endospores, that's where you need to go. Now, we mentioned if we go back to that continuum, you remember we put prions on the top, things that are hardest to get rid of, prions, and then we had endospores, then we had mycobacteria and protozoan cysts. And I pretty much said if we get rid of one of those levels, you can get rid of everything underneath it, and that's for the most part true. When we're dealing with enzymes, that's not true. Enzymes, if you remember, enzymes are very specific. We have developed some enzymes that will act against certain microorganisms. One example of that, we didn't come up with this, but it's a naturally occurring enzyme, but lysozyme. Do you remember lysozyme? Lysozyme was, lysozyme, we found it in bacteriophage. Bacteriophage would use lysozyme to break down the cell wall, the peptidoglycan cell wall. So we would use it there. We actually make our own lysozyme. Our tears contain lysozyme. A lot of our fluids, our bodies contain lysozyme, and that's part of our defense mechanisms. So lysozyme only works against bacteria cell wall. So it won't work against viruses, it won't work against prions or anything else, so it's very specific. We also said prions was very difficult to get rid of, and basically the only thing you could do was incineration. There has been a company that has developed an enzyme that will get rid of prions. It's called Prionzyme or something like that, and it's specific. It will get rid of prions, but because it's an enzyme method, it won't get rid of everything else. It won't get rid of endospores, so technically it doesn't sterilize because it's targeting enzymes. Okay, so that is a variable level. Put that in there. The last thing I want to mention in this chapter is just about our superbugs, our thoughts about getting rid of all bacteria, antimicrobial soaps. Have we gone too far? And I think we've kind of talked about this as we've gone through this class. But when I say the word germ, if I say germ, most people have a negative reaction. We think of germs now as causing diseases, and we need to get rid of them. And that was, and that was true. We got rid of a lot of the pathogens that were causing diseases, or we've reduced them, and we know that we want to get rid of those. But as we are learning more and more, we're finding more of the good things about bacteria, of our microbiome and the function of our microbiome. And so once we found penicillin in the 1940s, we started having our first defense, our first tool against microorganisms. We started overusing them. And we found that we have killed off a lot of our beneficial bacteria, and we may be causing some additional problems now. They think that developing countries developed countries like that have problems with allergies and autoimmune diseases, we may have killed off all of our good bacteria, and our exposure is limited, and our immune systems don't develop right, and we get these autoimmune diseases or these excessive allergies. So there's a lot of research going into that. We have learned that the more we use antibiotics, the more we put those into their environment, the more we are killing off the susceptible ones and leaving the most resistant ones to grow. And so we are now getting into those superbugs that are resistant to many drugs. So we're learning to do better. We're pulling off on that. We're only using these antimicrobials when necessary, using them correctly for the right purpose, stopping putting antimicrobial soaps in the market, stopping the practice of treating all livestock with antibiotics, whether they need it or not, stopping the process. That's why we get those antibiotic-free chicken or something you get in the grocery store, stopping the process of treating all crops, agricultural crops, with antibiotics, whether they need it or not. We're learning that we may be doing more harm than good, and so we're getting more judicial in our use of that. All right, so I did want to point that out. So all your friends right now who are worried about COVID-19. COVID-19, SARS-CoV-2, which causes COVID-19, is an enveloped virus. If you remember right, that is way at the very bottom. It is the easiest thing to get rid of. So people going, dousing themselves in bleach and Lysol may be causing more problems than they intend to in their fear and in their concern about catching this virus. We don't want to go overboard on the disinfection and sanitization protocols that we're using. So just be careful, you know, if your friends are running around with the bottle of bleach and pouring bleach on everything, just watch out for them. They may need a little help. So, okay, I hope this helps you in this chapter. I think that's the last slide, I'm pretty sure. So you guys let me know your questions in our Zoom meetings. We'll Zoom on Wednesdays and Friday at 9:30. And if you can't make those times, we can set up individual appointments or smaller group appointments. And you can email me questions. You can post them on the discussion board. I'd love to see you guys post questions there, because then everybody gets to see questions and answers. And I promise you, everybody has these questions and answers. So good luck. Let me know how I can help you. All right, take care, guys.